Hello, everyone. My name is Mariola Andrio. The title of this presentation is Pricing Conditional Value at Risk Sensitive Economic Dispatch, which is a joint work with Avinash Madhavan and Subhona Mishbose from University of Illinois at Urbana-Champaign. The deepening penetration of stochastic renewable generation has introduced greater supply side uncertainty into the power grid, and there are growing concerns over the ability of existing electricity market designs to adequately model and optimize against the stochastic nature of such resources. In this paper, we utilize conditional value at risk, which is a risk measure in order to model the uncertainty emanating from renewable generation. Because CVAR is a coherent risk measure, it ensures that the risk-sensitive economic dispatch problem will retain the convexity property of its deterministic variant, irrespective of the distribution of the underlying uncertainty. We explicitly take advantage of the variational characterization of CVAR from Rockefeller and Uriasef and formulate the economic dispatch problem and assign Lagrange multipliers to the power balance constraint in the system, the power flow limits, and the line flow limits, and the reserve requirements for the entire system. We define a vector of risk-sensitive locational marginal prices, denoted here by pi, as a linear combination of these Lagrange multipliers of the risk-sensitive economic dispatch problem. As you can see here, the definition of these prices mirrors that of classical LMPs. That is, there is a price lambda for balancing supply and demand across the network, but also there is a congestion component. We are able to show and illustrate a couple of interesting properties of risk LMPs. For example, when the underlying uncertainty of the renewable stochastic generation vanishes or disappears, then risk LMPs become equal to the classical LMPs. Moreover, when there's no congestion occurring across the network, then these prices become uniform at every location of the power grid. Again, a property very similar to those of classical LMPs. We can use risk LMPs to define the appropriate payments and rewards to all the market participants, but I'm not going to go very much into detail for that in the interest of time. What is important to emphasize here is the so-called revenue adequacy property of any pricing mechanism. As we know from the classical LMPs guarantee a non-negative merchandising surplus. In that case, typically the merchandising surplus is given by mu transpose F. As you can see here down there at the equation for the merchandising surplus, for risk LMPs, the merchandising surplus is equal to mu transpose F plus a risk-dependent component. In other words, what we're able to show is that we cannot guarantee a non-negative merchandising surplus in every possible realization of the underlying uncertainty, in this case being some type of renewable generation, for example, wind. So this is a property which is very important, but it's not possible for us at this point to guarantee that it will always be non-negative for risk LMPs at every scenario of the underlying uncertainty. In order for us to be able to compute a risk LMPs, what we do is we take basically n samples of the underlying uncertainty, which is wind generation, and we replace the expectation operation with the empirical mean of these n samples, and we solve the sample average approximation problem. Our preliminary simulations indicate that these prices indeed appear to converge somewhere as the size of the sample increases, it grows large. Our goal in the future direction is to show that these prices, which are obtained with empirical means, indeed converge to the Lagrange multipliers of the true local/original economic dispatch problem. So for our future directions, we want to establish analytically the asymptotic convergence of risk LMPs obtained through sample average approximations to the true risk LMPs, but also provide some sample size guarantees. We want to incorporate unit commitment decisions into the economic dispatch problem, but also provide a side-by-side comparison of risk LMPs to current practice.